Good morning, everybody. Well, afternoon, evening, whatever time it happens to be for you when you watch this. My name is David Shapiro, and I'm back with another episode about Raven AGI. In this case, I'm working on Raven's encyclopedic service. Now, what the Encyclopedia service does is it provides Raven with basically facts. It's what Raven knows about the world for certain. The reason that Raven needs this, even with a tool as powerful as something like GPT-3, is that GPT-3 doesn't really know what's true. And this is true of pretty much any generative model, right? A generative model takes input and kind of just runs with it. That's all it does. It's just an intuition machine. So what you need then is you need something that you say, yes, this is a set of facts that I believe in strongly. So that's what this is. I've got it running in the background. I'm running it against the simple English Wikipedia because it's much smaller. Let me show you about that real quick. So the full Wikipedia as of April 1st, compressed was about 19 gigabytes. Uncompressed, it's about just shy of 81 gigabytes. But the simple English Wikipedia is much smaller. Just under 1 gigabyte. And then you can see here I took a 4.2 megabyte subset to test on. And so basically what that means is that the simple Wikipedia is, one, it's in simpler English, which, you know, great. But also it's just smaller. So it's a complete subset of an English encyclopedia. So without further ado, let me introduce you to this project. So what it's doing now is it's actually going through and parsing out all of the articles into plain English. And the reason it has to do that is because here, let me just show you. By itself, it's pretty messy. So this is what Wikipedia looks like behind the scenes. You see there's some formatting that's familiar, but a lot of it, see like these double square brackets, that's actually a link, right? And so, well, with an offline dictionary, offline encyclopedia, I don't want links. This is just supposed to be a text document. So it's chock full of all kinds of formatting that we don't want, that I don't want to feed Raven. I don't want to give Raven XML or HTML or wiki markup. I want to give Raven plain text. So I had to write some scripts to just clean all this up and just extract the base, you know, the actual stuff from it. So then what I ultimately came up with was this. So this is what it looks like in JSON format. And you can see that it's not perfect, but it's much better. And this might actually not even be the last one because it still has categories in it. But either way, I removed the vast majority of the links and cleaned it up so that you can just read it. It's not meant to be rendered in a web page. You just read it. Yeah, this isn't the last one because it also has links. Okay, so anyways, this was the work in progress. Now, for the final script, you can see it's still running. Actually, some fun backstory. When I ran this, a previous version of this script against the full Wikipedia, it took about 18 hours to run. So yeah, or maybe it was 8. Anyways, it was a long time. I could make this faster by making it multi-threaded, because looking at my CPU resources, this is not taking a whole lot of resources. It's doing individual transactions with a SQLite database. It's not a heavy workload. And it's also just some basic regex, which you'll see in a second. Okay, so sorry, digression. Now without further ado, here is the actual script. So here's the file name. I showed you the XML file. I think this XML file is about 17 million lines long. So this is an export of the simple English Wikipedia in a single file. It's crazy. But there you have it. Let's see, I probably don't need that anymore. So I start with article equals an empty string. I could probably do a string literal, whatever. I create a database connection to SQLite 3 called Simple Wiki .SQLite. I get the cursor, and then I run start db. So this function, it does create table if not exists. And so basically, if you have to run this multiple times, you don't want to try and create the same table over and over again. So this just says if it doesn't exist, create the table wiki, give it these three fields, so title, article, and ID, and ensure that the ID is unique. So when you set a unique flag on a SQL database, it just says it guarantees that every value is going to be unique in that particular column. And that allows you to ensure that you don't get duplicates. It's the simplest way to ensure you don't get duplicates. There is one thing that you need to do to prevent errors later on, and I'll show you that. And then what I've got is create index if not exists, title underscore IDX on wiki title. So what that tells the database to do is to take the title column, that field, and create an index of it. And what that does is I'm not sure, I think, what was it? See, I looked it up. SQLite uses a B tree index, and I'm not exactly sure what that means, but basically what an index does is it makes it so that it's easier to search that column. And so when you do that, it says we're going to create another column that helps us find, if you search for a title, it'll help you find it faster. And so that means that the database will you'll get way better search speeds if you do a query such as, where did it go? Oh, I actually don't have a query in this script. So I haven't tested the search speed yet. And you see here I've got commented out doing the same thing, creating an index if not exists on. Okay, and we're back. Sorry about that. Had a little bit of a technical glitch. So still running. I left off where I was just telling you about the article index. The thing about the article index is that it basically doubles the size of the database. So we'll see how big it gets, and then I'll run this again, just so that way I've got multiple options. So we go to plain text Wikipedia and SQLite simple. So this is up to about 0.5 GB. The maximum size for SQLite is something like 218 terabytes or something like that. So even if this is over 1 GB, that's still going to be well within reason. So I'm not too worried about that. Even if we double the size by adding an index of the articles to 2 GB, or even if it goes more than that to 3 GB, I think it'll still be worth it because it'll basically give Raven a brain, a knowledge about the world. Okay, so the rest of the script. With open simple wiki underscore file name, so it opens this file with encoding UTF-8 as in file. We step through line by line. And the reason that I found that I had to do this was because the text files were so big, and it takes too much memory to try and do operations against the whole thing. In my initial experiments, I would try and do like split on page, and I would just watch the Python memory just climb. But we can ingest a file one line at a time, and what you'll notice is that because this is exported from a database in the format of XML, there are some nice consistent things. So for instance, the beginning of every page starts with this tag here, page. And then the title always is wrapped in these tags. And then the ID is wrapped in these tags, or actually the first one wrapped in these tags. And then the actual article body is wrapped in text. So there's less than text, and then it ends in less than slash text. And then the overall page itself ends in slash page. So because of that nice consistent behavior, it's easy to just read this one line at a time and then find what you need. So that's what I did. So if page is in the line, then we know that we're at a new article. So let's just start a new article. Else, if slash page is in the line, we know that we're at the end of the article. So let's go ahead and analyze this chunk. And then if we get a good document back, let's save it to the database. It's that simple. Otherwise, if we're just in the middle, if we don't see this tag or this tag, we're just add the current line to the chunk that we're working on. And so it builds up a subset of this. So it'll go from this page tag to the next page tag, and we can parse it from there. So the parsing it, doc, analyze chunk. So the first thing we do is we filter out a couple things. So if an article is a redirect title, I'm not really interested in that. So we just return none and move on. Otherwise, we split the title out of its tag. Simple enough. There are cases, I think I got a version that doesn't have it, where Wikipedia is chock full of talk, category, and other pages that are not actual encyclopedia entries. And I found that universally they have a colon in them. So if a title has a semicolon in it, I don't want it either. Otherwise, we run it through HTT, which is HTML to text. So it just de-renders the HTML into plain text. And then we say, okay, so there's the title. We get the serial number, which is out of the ID. So we split it from the first one, and then we split it, and then we split that out. And then the content. So the content is we take it out of the text tags, right? So we separate out the end text tag and the beginning text tag, and then we run it through the dwiki function. The dwiki function is where all the magic happens. So here's what we do there. First, we remove all the new lines because this is just going to be a plain text article. It's not going to be formatted for the web, so we get rid of all the new lines. We get rid of excess white space, so any tabs or other spaces become a single space. We remove any audio files. We remove the references at the end. So if you see the dash or the equal references, notes, or related pages, I'm not really interested in that because those are mostly just links. I've got this in a database, a searchable database, so I'm not too worried about that. We remove citations, which are in the curly brackets. Again, those citations are, we're taking this as true, and Raven can't read HTML. Well, I guess GPT-3 can read HTML, but we want Raven to speak in plain English. We remove the categories, which tend to be at the front of the article or the end. We remove links, and this isn't actually removing a link, we're just replacing the link. So here's an example, right? You might see this where it says autumn and then vertical pipe autumn/fall. And so basically what I want to do is just take the right hand bit from all the links, whether it's a simple link or a compound link or other, and then I just want this last bit of text. So that will give me just plain and simple links. And then I want to do the same with pictures. So pictures have, I think I've got an example right here. Yeah. Actually, this was a copy. That's audio. This is not correct. Here we go. Remove pictures. So pictures usually follow this format. We got file, colon, earth, flat, blah, 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 and then another pipe. And then the very last pipe, or a very last section, is actually a description, a plain text description. And so I want to actually keep that. So I created all the patterns that I found for images. This gets 99% of them. It misses a few. And then I just replace it out and then say, here's an image. And it puts it into the text. So that the fact that there was a picture there is captured. Raven can't see yet. Raven doesn't have any ability to process images. In the future, we might have a full version of Wikipedia so that Raven can see pictures and compare what's in his encyclopedic knowledge of the world with what he's actually seeing in real time. That's possibly a long ways off, and this is still running. I expect it'll take a while. We're probably, we're at half a gigabyte, so we're about halfway done, maybe a little bit more or a little bit less, depending on the size of the index. Okay, so we've de-wikied it. We've got all these functions that I've written. They're mostly just simple regex because regex is very fast. So we remove everything that we can. Links, URLs, simple links, citations. There's one thing that I haven't figured out yet, and that is the table information. So a lot of Wikipedia pages have table data in it, and I'm not quite sure the best way to represent that if it's just text. So that's on my to-do list. Then the last couple things we do are we use the wiki to plain text, WTP. Wiki text parser, WTP, which is just like anything that I missed, this will grab the last few things and give us a plain text version. And then we run it through the HTML to plain text parser one last time for also anything that I missed. And then there's a couple things at the end. Really, if I did this well, if I removed all the links and stuff, I wouldn't need this. So this is just me being lazy. I need to come back and figure some of these other edge cases out. And then finally, dwiki just returns the plain text version. And once you're done removing everything, you actually end up with about half of the amount of text. Right about half of what's on a Wikipedia page is markup. So if you just want a plain text encyclopedia article, it's about half. So then, assuming that all this works well, it returns a dictionary with the fields title, text, and ID. Okay, great. Now, because this is going to be pretty consistent, this is a great use case for a relational database. And so then I've got a really simple function, save to DB. I give it the doc, the connection, and the cursor. And so what it does is I set the little variable for the value. I execute insert or ignore into wiki values. So ignore gives it the ability to bomb out if it violates this rule. So I say ID integer unique. So let's say I needed to stop this and run it again. I don't need to do anything else other than just restart it. It will ignore, it won't recreate the table because the table already exists. It won't recreate the index because the index already exists. And so then it will just start running again. And if it's already processed one article, it will ignore it and move on to the next. And there you have it. That's it. Once this is done, let's see, where did it go? Sorry, can't see over my microphone. Once it's done, this will have saved all of Simple Wikipedia, the Simple English Wikipedia to a database file. And this will be a single database file, and that will serve as Raven's brain. So this is just the back end part. In the future, there's probably going to be better tools. I'm looking at this at Apache Solr, SOLR, which is an enterprise-grade search engine. So that's one thing that I'm looking at in order to have Raven's brain work so that he can recall facts about the world, encyclopedic knowledge about the entire world. And then GPT-3 is actually really great for parsing documents and summarizing documents. So like, let's say you want to ask Raven about historical conflicts in Cambodia. GPT-3 combined with the encyclopedic service will be able to recall that information easily, right? And then there's other things, like you could say, like, tell me about some of the most famous people in Russia, right? And Raven can search the encyclopedia, his encyclopedic service for famous Russians, and then summarize each of them for you, that kind of thing. But moreover, this will help Raven deal with other problems, right? All problems can be broken down into information problems. And the more information that Raven has access to, the smarter Raven is, right? It's not just going to rely on GPT-3 as the cognitive engine. Raven's also going to have a library, effectively a whole library in its head, allowing it to have access to all of human knowledge. Anyways, I'm gonna stop myself from rambling and call it a day. Check out the code for this. It's going to be up on GitHub. It's always up on GitHub. And then as soon as I integrate this into Raven, I will post another update. Thanks for watching.